Hello once again. Myself Vikas Shakya. I welcome you all on my channel VVS.org. And today is the second lecture of Python 3.8.1. And today I will discuss about the exceptions, libraries, and numbers, and a bit of mathematics which we use in Python. So let's start with those things. And in previous video, I hope you might have revised the concepts that I discussed yesterday. And without that, you should not proceed with this video. Okay, so if you have not visited my first video, then first visit that one, and then only you should come to this video. So let's start with today's video without any further delay. So let's start that one. So I've just opened my command cell here, the Python cell here, and today I'm going to tell you a few things about the libraries. Libraries, you all know, uh, if you have used any programming language, then you must be aware that there are a set of libraries that particular language uses when you are writing your own applications. Like in C and C++, when you write printf or scanf, these are basically the standard library functions, and a set of libraries have been provided. Those library could be static, could be dynamic, and you use them. You use those functions which have been defined in those libraries to write your applications, right? And similarly, you can write your own libraries as well. So we will move further in this course, and then we will learn that how we can write our own libraries. But today, let's see how we can import our libraries and what we can do with those libraries. So the basic library that has been imported, already imported with the Python application is sys, sys. So if you have to import that library sys explicitly, then you can write import sys. Similarly, you can write your own libraries, sys1, sys2. You need to write those your own libraries, and then you can do like same import sys, sys1, sys2, and then the library contains the functions will be available in your own cell. So if my syntax is correct, import this, and if the library is there, then we will be able to we will not be able to see any of the error messages on the screen. But if there is any problem, like if we are trying to import any library which doesn't exist, like this one, then it will simply give you an error. Like here, it has given me an exception, module not found error. So this is an exception. Whatever you are able to see here, module not found error, this is an exception. So what we can do at the same time, when we are talking about the exceptions, let me tell you a few things about the syntax of the exception handling. So I'm not going to discuss the syntax for try catch, try except, where the exception handling is done separately, because that's not a big deal or not a big topic, and not a kind of not a kind of topic where I need to devote entire lecture for that. So I will just tell you that how we write the code where we handle the exceptions, right? So uh, whenever you are trying to handle any exception, any scope is there for any exception to come, then you need to write the code in a function. Any function can only raise an exception. A block of code inside a function can raise an exception. So let's write one function. Def fun is the function name, and then when you start the function, before that you need to put a colon, and then we can write our own code. So if we have to write the code, then try, then colon, then again here we are trying to import one library which doesn't exist, which is sys1, and then let's write the exception handler except, and then what kind of exception it is going to catch. That is, what is the name of that exception basically. So the name of that exception is module name, module not found, basically not found error. This is the exception name which could come. So you write it here, and then here you write your own function, your own message that you want to print when this exception comes. So I have just written a function, just call the function print, and I'm going to write here print the library you tried to import was doesn't exist. Okay, so that's it. Now if we try to call this function, as from yesterday's video, you might be aware about the fact that if you have to call that function on your cell, then you can simply write fun, the function name, and then simply you can press enter, and then you know that imports this one will fail because this particular library doesn't exist. So that's why it throws an exception and it comes here, print the library you try to import doesn't exist, right? So the library doesn't exist, so whatever message I have given here, that will be printed here. The library you try to import doesn't exist. So this is the way you handle the exception. And more about exceptions we will discuss as soon as we will create more code snippets. But till then, let's move ahead and just keep in mind that you write how you write the basic syntax of exception handling. Okay, so let's move ahead with our other topic, and that is uh, to import the path, right? So import you if you want to see the path where all these libraries exist, and if you want to add some new paths to these libraries, how you can do that. So let's see that one. As of now, we have seen we have imported sys1, not sys1, basically sys. I have imported sys here. Again, I need to import it. Actually, I don't need to import, but basically I'm just trying to rewrite so that it becomes cleaner again. So it's import sys. So now the sys environment is imported, about all the libraries, all the things, whatever we want from sys library, that all exists here. That is now available within this cell. So if you want to see that what are those paths from where the library contents will be picked, then we just need to print the sys dot path, sys dot path. So these are the paths available from where our Python will try to pick the library contents. Whatever library uh, there are available, those are all available within these paths only. So these are the paths which have been which have been added by the environment when we were installing the Python. When you install the Python, at the same time, these paths are set for the sys. Suppose if we want to add one more path to this, then what we'll need to do, sys dot path dot insert, right? So insert basically takes two arguments. The first argument is the index at which I want to add the path. Suppose I want to add the path at the beginning, so I will give the 0 index, means the first index. At the first place my path should be added, and that path should be C, and it's suppose it's Vikas, and it's notes, or you say the GK notes, right? So this is the path which I want to add as an additional path, where I want to put my additional libraries. So this is the way I need to insert it, and I can put my index. I can pass my index in the insert function wherever we want to add it to. So now if we press enter, and now if you try to print all the paths, sys.path, then you will be able to see this newly added path. You can see it here. This is the newly added path now. So within this cell, now this path has also been added, right? So this is the way you can add a new path to your cell, and you can put your new libraries there, whatever you have created or whatever libraries you found from somewhere else, you can put there, right? So this is the way you can do it, right? So let's move ahead and let's see what else we have for today. The other thing I just want to discuss is about the function documentation. You write the functions, and you sometimes you provide the comments. Sometimes, or most of the times, you should provide the comments to basically provide the purpose of the function, right? You might have written such kind of code where you write a function, and on the top of the function you write the purpose of that function. You describe the number of arguments it takes. You describe about those arguments, what those arguments do, and many other things you can do, whatever you think, like whatever information you would like to tell to the users of those functions, right? So if we have to document our functions in Python, then what we need to do? We need to write a function name. Suppose the name is fun1, then I put a colon, and then I need to put three quotes, double quotes. Anything written between these three double quotes will be considered as the comment and as the documentation about this function. This is the information about this function, right? So you can write it on other line as well. So you can put it like here as well. Anything which has been written in between will be considered as comment. So this is the only comment. This is the dummy content I'm putting as a comment, as a documentation rather. So this is the way you need to write it, and then you can write your own code, the actual code which will be executed. So this is the way I have written my function. And if I want to display the documentation about this function, then what I need to do, I need to just give the function name fun1, and then you need to pass this attribute doc. You want to know this attribute doc, and this attribute contains the contents of the function, the documentation about the function. Okay, so you can write this and you can just press enter and you will be able to see whatever I have written there. Okay, so whatever I wrote there, this is the information about this function, and this is the only comment. Everything has been displayed here. Okay, so this is the way you can put the documentation about the functions. Okay, so I think you might be feeling comfortable about these things, like how to import libraries, how to add new path for the libraries, and how to define a function and how to document the function, and how to insert a new path for the libraries. So we have just done a small thing as of now, and again a new small thing I'm going to discuss, and not a tough topic at all, and that's the basic data types that are used in Python. So let's discuss one by one. So first discuss about the Boolean values. So you know that Python is not a strongly typed language. It doesn't care about the fact whether you have declared any variable or not. You just need to give the name of the variable, and then you can just give it a value. So if I'm giving a value true or false, then it means that our interpreter will know that this variable is basically a Boolean variable. So if I write b is equal to true, then it means then it's a Boolean variable and the value has been assigned as true. So if I try to print it, print b, then what will be printed? It will be true. Okay, so b has been true has been printed with the help of variable b. So in variable b, I assign true, and similarly you can assign false, and you can see it. So we can do one more thing. B is equal to 10 is greater than 9, which is not true. So if I print b now, okay, it's true because it's 10 is greater than 9. I was just thinking reverse. So it's true, but if I write b is equal to 9 is greater than 10, then if I print b, then what will happen? It will give me false, right? So this is the way you can, I think you understood what I'm trying to say. Okay, so let's move ahead with other data type, the integers, not specifically integers, we should say rather numbers. Okay, so numbers are of two types. They may be integers, they may be floating point numbers. Integers are like 19, 20, like that, and floating point numbers 19.1881, blah blah. So these are the things we say the numbers. So one is integer, the other is floating number. So let's see that how we can assign the values for the numbers. So it's simple. If you assign it like n is equal to 10, then it becomes a number, simple number. And if you print it, print n, then it will give you the value. uh, but the main thing is the arithmetic we perform with these numbers, right? So let's not discuss much about it, how to assign and what else we can do. Let's move directly ahead to the operators and the operations we can perform on the numbers, right? So addition, subtraction, division, multiplication, all these things are known to you. The only important thing here I need to discuss is the division, right? Why? Because for division we use this operator to divide anything. Like here I divide, if I divide 10 by 2, then it gives me 5.0, right? And the other operator to division is 10 double divide by 2, it gives me just 5. So there are two operators for division, right? So we need to understand about these two operators and what is the difference among these two. Okay, so let's start from the single division operator. So 10 divided by 2, it has given me 5.0. So you need to remember that uh, it doesn't matter if you have provided the complete integers. Basically, our single division operator assumes both the numbers as the floating numbers, right? So whenever you will do single division, then it will give you a floating point as a result. So if I write 12 divided by 5, then it will give you 2.4, right? But if you give 12 divided by 5, then it gives you suppose uh, you give it like 12 double divided by 5, then it will give you 2, right? 5 2s are 10, and then it simply round it off to 2. So when you use double division operator, then it uh, simply gives you the value, the complete divider, and not the fractions, not like 2.4, right? So this is the way it works, right? So uh, one important thing about this double division operator is, like, if you write 14 divided by 5 double division, then it should come like 5 point something, which could make it near about 3. But this will give you the floor value, not the ceiling value, right? So 5 threes are 15, but it will give you 2. And although when you divide 14 by 5, then it will give you 3.8 something, right? So 2.8, right? So if it is 2.8, then it is close to 3, but it will not round it off. It will just truncate after after the decimal. It will truncate everything which could come after the decimal, right? So it will just give you 2. So it will round it off. It will not round it off. Basically, it will not round it off. It will basically truncate it to the floor value, right? So this is the main important thing about this double division operator. If I do like 14 division by 5, then it will give you 2.8, which is almost 3. So if you round it off, then it will become 3. Basically everything, so every time we do this double division operator, we may expect that it will round it off, but it's not true. It will not round it off. It will just drop to the floor value, right? So if I again a new I can take one more example. Suppose I have written 14 minus 14. Rather than 14, I have written minus 14 divided by 5. Then what it should give? It comes to minus 2.8, right? If I write this, then it will come minus 2.8. But so it's like, if I do it like minus 4 double division by 5, then what should be the result? It goes to minus 2.8. So it should round it off, and it should fall to the um, floor value. So what will be the floor value here? If the division is done, the floor value should come as minus 3. Okay, because minus 3 is smaller than minus 2. Okay, so that is the difference when we divide a number by using the single division operator, and when we divide a number using the double division operator, right? So this is the way these two operators work. So this is all about these two operators, and other operators like plus, minus, multiplication. Those are again the same, and they are used in the same way you used to do you used to use them in C++, C, or in Java, right? So uh, you need to keep this in mind only. Other things are pretty simple. Okay, so let's move ahead to the next topic. The next topic is to raise any number to some other numbers, to the power of some other number, right? So if I have to raise 2 to the power 3, then I can write like this, 3. So it is equal to 2 raised to the power 3, and it gives me result 8. 10 raised to the power 2 will give me 100. So this is the simple operator, so just need to remember it. Okay. Okay, so another mathematical operation that we can perform is the fraction. Okay, so if you have to perform the fraction with the numbers, then you first need to import the fraction library. Fractions is the name of the library. Import fractions, right? Suppose you have imported the fractions library. Now we need to create a fraction. Suppose we want to create a fraction 2 by 3, right? So what I will do, suppose I want to create a fraction and assign it to a variable, then what I will do like x is equal to fractions dot fraction, and 2, 3. So first argument is the numerator and the other argument is the denominator. The first argument is numerator, which is 2, and the second argument is the denominator, which is 3. So it makes 2 by 3, right? So if I print x, then it will again print like fraction 2 by 3. Okay, so it's 2 by 3. Okay, and now we can perform other operations as well on this fraction. Suppose I want to multiply it by 7. Okay, so let's multiply x by 7. So x into print x into 7. What will come? 14 by 3. Okay, so all the operations that are performed on a fraction you can perform this way. And suppose one more operation, I want to perform one more operation, print, and I want to multiply 2 by 3 by 3. So x into 3. So what it should come? What should be the result? So I multiply x means 2 by 3 with 3. So 3 to the 6, and the denominator is 3. So what will be the result? The result will be 2, or you can say 2 by 1. Okay, so it's 2. So it basically performs all the simplifications as well at the same time. Okay, so you don't need to worry about whether it will be able to do the simplification or not, and what it will do with your fraction if you have done these kind of things. So this is all about the fractions. You can easily understand what I'm trying to explain here. These are simple topics. It's just like these are the features that are not easily available and not basically useful when you are there. These are not there. They are useful, but they are not there in other languages like C or C++. You need to write your own, and then you can do all these things. But in case of Python, you will find them readily available. Okay, so let's move ahead. Apart from fractions, what else we needed? Okay, so other one is the trigonometry. We can perform trigonometry as well, like import math. If you have to perform the trigonometry, you need to import the math library, and then you can perform your trigonometrical operations like math dot sine theta. You must be aware about the sine theta, tan theta, and cos theta. So what is the value of sine 90? It's near about 1, right? So it will give me 0.89399. So this is the way it will display. And if we write like math dot cos theta, cos 0, then what is the value of cos 0? 1, right? So it will display 1 as the result. So these are the basic mathematical operations you can perform, and there are many others as well. You can read them online as well, but there is nothing like in them. There is nothing which I need to explain it to you. These were the basic things, and these were the some tricky topics like single division operator and the double division operator. These were basically a bit tricky one, so that I wanted to explain it to you, so that's why I included them. But I will not include everything which you can easily uh, take care of and you can easily understand, right? So this was all about the mathematical operations and the exception handling. And I think for today it is enough, and we can meet tomorrow once again, and we can from tomorrow onwards we can start the new topics and some useful topics which are available, and which are the which basically which are the important topics in Python, and which are the useful topics as well in Python, and you must know about them and you must be aware about them as how to use them, right? So from tomorrow onwards, I will start the library functions, library uh, standard libraries provided by the Python, like list, dictionaries, and tuples, all those kind of things, which has been provided by the Python library. I will discuss one by one in the coming videos. So you can just try these things on your own on your PC, and let me know if you want to know something else, or you have any doubts from today's lecture. And we will surely meet soon, and I will just upload a new video very soon, maybe tomorrow or day after tomorrow. So till then, please like, subscribe, and have a great day ahead. Okay, bye bye.